Hello, everyone, and welcome to today's SANS webcast, Zero Trust-Based Access Management and Remote Access for OT, IT, and Cloud, sponsored by Xage Security. My name is Mary Lynn Gollier of SANS. Today's featured speakers are Stephen Mathezer, SANS Certified Instructor, and Vishal Gupta, Xage Security VP of Product Management. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
All right, thank you, Mary Lynn. Welcome, everyone. As Mary Lynn said, I'm Steve Mathezer. I'm a SANS certified instructor. My focus is industrial control systems, I will certainly lean that way throughout this webcast, but what we talk about today is applicable, as the title says, to OT, IT, and cloud. So we're past intros. Maybe, Vishal, do you want to give yourself a bit of an intro before I go on?
Sure. My name is Vishal Gupta. I'm VP of Product Management at Xage. My background is in cybersecurity, cloud security, data security, and very happy to be here and for this opportunity with SANS. Thank you.
Awesome. And for those that are interested, I teach ICS 410, which really has a focus on architecture of OT environments and the IT-OT boundary. That's kind of where I spend a lot of my time, which also touches on remote access and authentication. And as a part of my day job, I also do a lot of assessments and architecture work in OT environments. So I see a lot of these challenges firsthand, and that Xage very much intrigued me in terms of how it can solve some of those problems. So that's what we're going to talk about today. At a high level, I will quickly review some of the challenges we see in IT, OT, and cloud. I'll touch on the critical controls for ICS cybersecurity, and then we'll get to Xage and how Xage Zero Trust Access Management can help. As far as those challenges go, there's of course many, otherwise none of us would be working in cybersecurity, but we have a threat landscape that is continually evolving, continually changing. And when we talk about OT, that's happening at a much faster rate than the technology that we are using in those environments. We have far more complexity, far more automation. We want data. We've got to move that data in and out of the OT environments or in and out of our companies and organizations. And there's a huge variety in threat actors, their motivations. We have everything from the nation states down to the people just figuring out what they can do. And zero trust, I hope we can all agree that zero trust is probably an overused term, but that's why we put the word principles in here. Whatever you may think of zero trust, I hope we can all agree that the foundational principles that underlie zero trust are sound, right? Every organization can benefit by having stronger visibility and control of the many interactions between people and devices. So today, there's a lot of great principles that I see a lot of organizations struggling to apply. They don't have identity-based access management. They don't have tooling to manage security of data. And especially in the ICS world, we have a lot of devices that don't have a lot of security built in. Although, of course, with IoT, we're starting to see a lot of those creep into the IT world as well. And remote access. I mean, obviously, we've had COVID-19. We have skills shortages. We're working 24/7, flexible hours now, and all kinds of different personas, right? When I say persona, I'm talking about, sure, every company has staff that need remote access, but what about support? What about vendors? What about partners? What about other third parties? And different ones or different groups in each of those categories as well, different access requirements. So we're using remote access more than ever before, but we don't necessarily have the structure to control or manage that, which leads to what I call too much RDP and free. And that's true everywhere. I see that a lot in the ICS world. And what I mean by that is, in a good case or best case scenario, we have multi-factor authentication. We have strong password policies and controls around remote access. We check on what kind of systems people are using to connect or where they're connecting from, all of those kinds of things. And then once they're connected, quite often they get an RDP session into some terminal server. And that's the end of it. We have no visibility, no control. And once logged in, those people can do anything they want. We, in a best case, I would say today in most ICS environments, we see a terminal server. We might see some good authentication to get somebody there, and maybe even a little control over the applications they can run, but they can run those applications and take action or act on any system in the environment once they're in. And that to me is a huge risk, because one account gets taken over and then an attacker has access to everything. So for those of you that are familiar with the Security Weekly podcast, the question is always, what is the problem you're trying to solve? I always that's my focus. I have a technical background, of course. When I'm looking at a new product or a new vendor, new piece of software, I always want to know what are the problems they're trying to solve? What does that mean to me? And the second piece I want to know is how does that work? How am I going to implement it? What are all the pieces? So those are some of the questions we're going to try and answer today. If you're not familiar, I encourage you to Google the 5 critical controls for ICS cybersecurity. There is a SANS white paper specifically on this topic, and this has become a bit of an industry consensus for the top 5 things that you should do to secure your ICS environment. And I think we can hopefully also agree that incident response is necessary. Something bad is going to happen. So that is our the first control of the 5 critical controls. But architecture is where we can have the biggest bang for the buck, if you will, or the biggest impact with the least effort. That's my jam. That's what I focus on a lot. And we'll talk about architecture as we go. Visibility and monitoring, especially in OT, is a huge gap. And of course, we all know that we can't protect what we can't see. I've already touched on remote access. We have people working from everywhere all the time. We need to get rid of that RDP and free kind of posture. And then risk-based vulnerability management, particularly difficult in OT, but it becomes a lot harder if we don't approach it in a risk-based manner. What I mean by that, and that's, we won't really talk too much about vulnerability management, but what I mean by that is we need to fix the important things and spend our effort on the important things and not spend a lot of time churning on things that don't really matter, where there's other vulnerabilities or other reasons that the vulnerability is irrelevant. When it comes to Xage, it's these middle 3 that Xage supports quite strongly. There's defensible architecture, monitoring and visibility, and secure remote access. And I've worked with a lot of vendors as part of my various day jobs. In a previous role, I had a lot of best of breed products, right? On the security team or in the security practice, we had a good 15 different products. And it got to the point where they became impossible to manage. Each one of them was great, but they were awfully difficult to manage, especially on a small team, which always is changing and shrinking and so on. So I'm generally in favor of picking a smaller number of products or horses that collectively can cover the bases. And that's why I highlighted the fact here that Xage can help us address 3 out of 5 critical controls for ICS. So that's what we're going to talk about. The Xage solution is a platform. There's a fabric that provides us with many key capabilities, and we'll go into some of those in depth. But at its core, we have identity-based access management. We have zero trust remote access, and we have dynamic data security. Vishal, do you want to expand on those a little bit here, or should I go on to the next slide with the details?
Sure, Stephen. Yeah, let me add some words here as well. So I think you said it right, Stephen. One thing I would like to highlight here is that there are 3 key problems that we are trying to solve when it comes to OT, IT, and cloud infrastructure. And we are doing it in a fashion that everything is done in a very seamless user experience, and it's very easy to consume via distributed technology. And we're going to go into it, depth of each of these tools. But first one is the protection. How do your end goal as a business owner is to be able to protect your assets, whether you got critical infrastructure, whether you got storage systems, how do you protect those systems? Second, once you have understood that, okay, my assets are protected, you have to be able to access those remotely or locally. And because you got to keep your business running, you have to enable your operators or technicians to be able to access that from any point of the world without actually going physically to the site. Third is the data part, whether it's a sensor, whether it's a RTU or PLC, whether it's care system, historian, data lakes, your data is flowing through the nested topologies of networks from less secured zone to high secure zone and vice versa. So how do you control the data security of that aspect? So Xage platform, when it comes, it acts like a fabric which sits across your distributed settlement of your assets and gives you the protection through its zero trust policies, and gives you access control at each of the operation, whether it's from user to device, device to device, and gives you visibility and protection even at the protocol level. How, whether it's VNC, RDP, or even level 3 Modbus protocol, it can give you protection at that level. Remote access, of course, how do you access remotely? And of course, how do you audit every interaction? And how do you do it without putting any agents or anything on your clients? Third is dynamic data security, which allows you to actually control the data flow from point A to point B without actually letting anybody spoof the data or temper the data. And even if they do it, there's a way for the system to find out and let you know and let you verify the data after the effect. So, and everything is offered as part of the platform. So you wouldn't have to deploy. Once you deploy the platform, you have everything at your disposal. So you could pretty much enable the features based on the licensing you got. Back to you, Stephen.
Awesome. Thanks, Vishal. So drilling down a little bit, these are some of the capabilities that Xage brings to the table. We've got, honestly, everything on the left is closely related to secure remote access, federated authentication, single sign-on at multiple layers. And we'll go into that in a little bit more detail. But the idea being, of course, we want to authenticate people. We want single sign-on where possible. We want MFA where possible. And Xage brings us an interesting capability to perform that authentication and validation at multiple levels throughout the environment, whether that's in the cloud, in IT, different levels of OT. So we'll get into that a little bit more as we go. But that's a key component of the secure remote access. In addition, of course, we want the access control that comes along with that. And then some of the things that you might expect to see from a privileged access management solution, right? Password vaulting, just-in-time access, session collaboration and recording, and all of those things. So, there are a lot of privileged access solutions out there. There's a lot of remote access solutions as well. We don't often see those things together, or we don't see them together in a package as often as we probably should, because they're both key for remote access. And as Vishal said, Xage also provides data security. So file transfer is a bit of a challenge, especially in OT environments. Doing that securely is a huge advantage. Controlling access to devices and interactions between devices and users and devices, talking to devices, et cetera. Actually being able to get down to that level, especially in OT, so that we can segment our networks, right? Again, zero trust network, whether it's by identity, user identity, or device attributes. And we want to manage all of that centrally, and we want that to be enforced centrally without a lot of interaction from our perspective.
Can I add one more point, Stephen, really quick?
Mm-hmm.
So, the Xage platform is meant to solve the problems for really, really large organizations. but it is an extremely good fit for smaller organizations as well. Speaking of the large organizations, pay close attention to multi-layer access management and multi-layer AD integration. If you look at your organizations, you may have a different SOC team for IT, different SOC team from OT. Sometimes you may have different compliance and different control systems, even for DMZ. You may have a different set of policies for each of these layers. How do you actually integrate your IDP systems, your MFA systems, your separate SOC compliance policies in an autonomous fashion by your admins into the same system? Xage empowers you to do that. So you wouldn't be constrained that you have to ask somebody that, okay, you got an Active Directory, let me get your users from your Active Directory there. We let you bring in your own department's Active Directory, MFA policies, zero trust policies at each layer of the Purdue model. So you have the same solution flowing across your different departments, IT, DMZ, OT1, OT2, at the same time, having a single control plane and single set of policies spread throughout your organization with a single management console. So there is no conflict when it comes to working with different teams. They can have their own rules and regulation, but from management standpoint, you still access the same product without actually multiple patching and tooling at great extent.
Perfect. I'll let you keep going here if I can advance my slide and talk about the Xage architecture and how this all works.
Yeah. So first of all, our architecture is distributed, and its backbone is based on consensus-based distributed ledger technology. What does that mean? That means that not only we help you protect your infrastructure in a highly secure fashion, we are ourselves breach-proof. Even if you try to breach our fabric, we would alert you that something got changed and you should take an action. So not only we are offering the protection, we are using the same technology to protect ourselves. Two other benefits that comes with the Xage solution is it's a distributed deployment, but it is more like an overlay on top of your network. It doesn't require any agent. It doesn't require any thick clients. It does not require any changes or re-IPing of your network. Every single artifact, every single asset of your network stays the same, and we come as an overlay. If you see on the architecture diagram on the right-hand side, imagine you got your IT layer, you got your DMZ zone, you got your OT zone. As I said previously, we have a notion of Xage fabric, and each fabric has got Xage nodes. So the cubes, the blue cubes that you see, those are the Xage nodes. And these are the entry points into the fabric. So when you have a technician wants to access anything, they would like to log in into these Xage nodes. They are web applications. Internally, our architecture is very modern, scalable, based on microservices, but it is well adapted to solve the most legacy problems meant for critical infrastructure with appliances and devices baked into concrete, which you cannot access physically. There has no credential management, but as an overlay system, we can give you the same level of security that the most modern IT setups get today. So, and if you look at the flow of the diagram here, we call it a multi-hops solution. What does that mean? That when you try to access remote access, say you're coming from cloud, and you have to go through IT, DMZ, and into OT to access a PLC sitting down in front of the OT workstation. You will try to access the workstation from a browser-based application. It's a proxy that we have written, and we support proxy for RDP, VNC, SSH, Telnet, with the same user experience. You never see the command, you never have to open a VNC or RDP. You actually access your device. Internally, we use the protocols, and we tunnel those protocols from secure IPsec tunnels all the way to your asset. What that gives you is protocol break and reconstruction of the session at each of the intersection of the nodes, as well as it gives you separate integration points with your own Active Directories. For example, here you see your IT may have Azure AD available. So we can talk to SAML and get you identity management and let you come through. When you hop into the DMZ, maybe today you're using a jump server there, but using our fabric, you don't have to access the jump server, but you will get the jump server level of security. But if you bring in another Active Directory or Azure AD into a DMZ, we can prompt you again that, hey, re-identify yourself because you're going into more secure zone. You will have to re-identify yourself, and so on. Once you go into OT, you'll have to re-identify yourself. And at each layer, we can optionally enable another level of authentication, or OTP-based authentication. Now, on top of that, we also have device level MFA. So even if you reach at the device level, we can enable device level MFA for each of those devices. So net, this architecture solves some of the biggest problems that we have in the critical infrastructure industry today. But the way we solve is very simple, based on the three notions we discussed in the previous slide. Very simple user interface. However, all the complexity is taken care of by the product itself for you. So that's the summary for this architecture. Back to you, Stephen.
Awesome. Thanks, Vishal. While we've got this slide up, I'll just answer the question that Merrick put in the Q&A there. He was asking why we have an HTTPS server down here in OT site 2 in the bottom right. And that could be, and why is it not in the DMZ? That could be anything. For our purposes, I'll say that that's likely to be something like a data historian or a human machine interface, or some sort of for control of the OT environment. So those would be that would be a web server that is not typically exposed to the internet or exposed to outside networks. It's meant for people within the OT site to manage their infrastructure. However, as we all know, people aren't always on site, or you need support from a vendor or what have you. So what Xage is bringing here is it's allowing us to access that HTTPS server remotely, whatever it is, historian, let's call it. It allows us to access the historian remotely. A vendor might be able to get in and help troubleshoot, but that is happening over a secure tunnel with authentication, potentially at multiple steps with MFA layered over top of that. So we in this case, Xage is allowing us to keep that server out of the DMZ and off the internet, so that we can access it securely through the fabric.
Yeah, one more thing I would like to add here is, as part of the fabric, like Stephen said, that it could be anything. But what it also means is that we support offline access that I did not mention in the architecture. Offline access means support OT site 1 goes totally offline from the rest of your infrastructure. As long as we have our Xage node running there, you could have a HTTP server sitting there, or you can have a technician go in there, and if they try to access their pre-configured assets, they will still be mandated to pass the Active Directory, MFA, and the policy management that has been federated to begin with. So even if it goes offline and our Xage node sitting in that site is not able to talk to the rest of the Xage fabric, you still have the same security enacted in that particular site. So basically, and we are able to do that because we sync across the fabric continuously. We manage the credentials in a distributed fashion, and we bring the credentials together. And when you're trying to access your Windows system or any application, you would not have to remember the passwords, because all the passwords could be pre-configured by the admin. And when the technician comes in, he or she just has to identify herself based on her AD identity. And the devices will have a single sign-on without actually him entering the device username password.
Perfect. Thanks, Vishal. So we'll get into some details as we go here, because what I want to talk about a little bit is what I thought was cool about Xage, right? So it's solving some of our problems with secure remote access, with monitoring and visibility, with data security, and so on. So here are some of the features that appealed to me, I guess, and how they solve some of the challenges. I'll start with RDP and free. I mentioned that earlier, right? We tend to let people into environments. Maybe we secure their initial access, but then they are free to do what they want. If you look at the Dragos report for what was it, 2022 year in review, 54% of incidents that they worked on in ICS incident response context involved shared credentials. So if 54% of incidents came from shared credentials, and we let people do whatever they want once they've RDP'd in, I think we have a pretty big level of risk here, credential abuse in general as well is a major vector for initial access and lateral movement in these environments. So with Xage, we have layers of validation, as we've talked about. We can authenticate against multiple directories or against the directory that's appropriate for the level of access that the user is being granted. And that can include different identity providers and different and multiple MFA sources as we go. So you're not just getting in with one credential. If you move deeper into the environment, we can require additional authentication. So this helps with attacks that rely on human error, social engineering, right? Anything that's trying to get your credentials. And I know defense in depth is also an overused term, but it's kind of a defense in depth authentication strategy. If one credential is compromised, you can give yourself a backstop there with another level of authentication, and you can force users to reconfirm their identity. So even if they've authenticated in at one level, if they want to move further, what if someone's taken over their session or gotten access to their session in some way? We can authenticate them as they continue through the environment. Compromise of an individual authentication factor is not going to be as big a deal. So we can constrain, I guess, any sort of breach or vulnerability that way. So credentials are a big problem. Just one last statistic there, CrowdStrike also said, from their perspective, 80% of attacks leveraged identity or credentials, and that has grown at greater than 100% year over year. So credentials are a huge thing that we need to manage, and that's something Xage can help us with. We will talk about it more later. There is also, as I mentioned earlier, a privileged access management or a credential vaulting component as well, and that just kind of puts the cherry on top. Did you want to add anything before I move on, Vishal?
No, this is good. Thank you, Stephen.
All right. The second bane of our existence in OT environments are legacy devices. If you go to market today, you can get some pretty capable devices, right? You can get PLCs and other control systems that support all kinds of bells and whistles, from encryption to centralized authentication and logging and monitoring and all of those things. But the fact is, I couldn't even wager a guess as to how many of the devices we have out there today are what I would call modern or not legacy devices. I suspect it's a pretty small percentage. So we have a lot of devices out there that don't have basic security controls. They do what they're told. You don't have to authenticate to them. You don't have to validate who you are, what you are. They just do what they're told. And sometimes that there's device-to-device communication where we have devices telling other devices what to do, and none of them are really have any protection against somebody spoofing those devices or just connecting to them and telling them what to do. So that's another piece of what Xage can help us with. It can help us discover all of those assets and their interactions by monitoring the network communication. And then we can actually strategically locate Xage enforcement points, which will look at device attributes and user identities. And I think of it as a transparent firewall, basically. Control what can go, what communication is permitted between users and between devices. And in a well implemented, we can also do this, because as soon as I say transparent firewall, I know there's a lot of OT folks, there's a lot of engineers out there saying, get off my network, right? I need to be on site. I need to be managing my systems. And this is where we can position the enforcement points such that they provide this protection for people coming in remotely. But if you are physically there on site, you're behind that device, or you can be behind that device, so that we're never going to get in the way of you actually doing your job, managing the site, and keeping the world safe, right? So that, I love that aspect of this, because trust me, I've tried to put security solutions into a lot of environments, and it's always yeah, but what about that 1 in a million situation where you're going to prevent me from doing what I want? So we can implement this in a way that still allows those people that are physically there in front of the process to do what they need to do. And that's for and that allows us to control, as I mentioned, the machine to machine, the users talking to machines, and the users talking to users, all with encryption layered on top. So the Xage nodes can encrypt our communication or tunnel it basically from location to location if we need that capability as well. Did I cover it all there?
Right,
Vishal?
yeah, I think you did. On encryption, another layer of encryption can be enacted using the enforcement point between the devices, which could be going over the wire, but we can use AES-256 encryption to actually encrypt the traffic. One thing I would like to add is that on the slide, we covered some of the fundamentals that we do, and you can imagine that how many devices, depending on thousands or hundreds of thousands of devices you may have in your infrastructure. But the way we let you create the policies and apply those policies, the operational cost of achieving the outcome that we're talking here is very, very minimal. So we let you define the policies, we let you group the users, group the policies, group the devices, and map those devices to the user groups in a way that you can apply these restrictions. Like in a day, you should be able to get a coverage of 80% of your infrastructure the day you decide to put Xage in your infrastructure setup.
Awesome. I touched on third-party remote access, or remote access anyways, a little bit, but I want to kind of zoom in on third-party remote access. This is a problem everywhere, a growing problem, as I mentioned earlier, but in OT, we see this in spades, right? We depend highly, in many cases, on third-party vendors, on integrators, on the experts in the systems that we are managing. And those experts are few and far between, which means they're coming in via remote access. And every one of those personas is different, right? We have staff, but those might be engineers, they might be technicians, they might be operators. That's just within staff. And then you have partners or vendors. Maybe you have different vendors for different control systems. And then they have different roles as well of the, the engineers, the technicians, the operators, the different expertise, programmers, whatever it is. And that multiplies very, very quickly, multiple sites, multiple vendors, multiple control systems, and suddenly we have dozens or hundreds of personas that need remote access. And, honestly, they're sharing credentials, they're sharing access. We don't really know what they're doing. And back to the RDP and free, we can't really constrain what they're doing in a lot of cases. With Xage and the Xage Fabric nodes, we can, number one, give them an easy, or I shouldn't say easy, a frictionless way to get into the environment while continuously verifying that they are who they are. But this is where some of those privileged access management capabilities come in. We don't need to give them credentials to share. We can vault credentials and log them into things without revealing those credentials. We can do multi-party session collaboration and control that in terms of what level of access each party in that shared session can have. You can record that session. Of course, an audit trail comes with that. And all of this happens per user, per location, per action. So this, I see this as a huge challenge, especially in OT. And there's no one stop or one size fits all solution, but Xage brings a lot more tools into our repertoire to allow us to control this kind of access as well. Coupled with remote access, we have the challenge of moving files and data around. As much as we would prefer not to have this problem or would like a better handle on it, we're constantly moving files around, again, especially in and out of OT environments, whether that's firmware, project files, configuration files, backups, operational telemetry, business data. We've got to get data and files in and out of the environment. And I tell you, this is a significant attack vector. I've seen open file shares sitting there with not just an open file share, but no control of who can access what on those file servers. Just the fact that it is a file server, that's an attack surface, SMB file shares, right? There's a huge attack surface there. And then if it's not a file server, it's USB. So Xage does also give us the ability to move files through those fabric nodes, right? Again, through those relays or those proxies, we can move the files layer by layer with based on the same identities, controlling the access maintaining the data integrity. There are options for the for scanning or visibility into the data that's moving around, and all of that without exposing file servers. And which also, I didn't mention this, when you expose file servers, you tend to make Swiss cheese of firewalls, because now we've got to allow authentication and management and all of those things. So that virtual layer, or that fabric that Xage lays down on top of our network, gives us a great way to also move the data in and out and around without all of those risks that typically come with that kind of activity.
Yeah, one thing I would like to add over the data part. So files are something that Xage helps you transfer from one point to another through the secure tunnels. Along with that, we also let you move the data. Data as in the data that's coming from your sensors, from your SCADA systems, or any other storage systems that you would like to move securely and have access control on that. For example, one of the recent project that we were doing, where there were 2 refineries, and the data was coming from each of the refineries, getting collected from individual SCADA systems. And then the data is actually going to a central processing plant where they're massaging, running their artificial intelligence models on top of the data, and then sending the data to the respective parties, the final destination. They wanted to make sure that the data that the final destination parties are actually getting is non-tempered. It's a difficult problem to solve, because how do you actually mathematically prove the data has not been tampered? That's what Xage Security solves using dynamic data security, that any data that's coming could be streamed into the fabric, and we will fingerprint the data, we will annotate the data, and then we will make sure we'll cryptographically encrypt the data. And when you get the data on the receiving party, you can actually verify cryptographically whether data has been tampered or not. And goes without saying that as the data moves from secure networks through the Xage fabric, it is actually going through the tunnels, so it's secure in the transit as well. That data optionally can also be encrypted. However, the data can always be verified, and rest assured that you can always make sure the data is non-tempered for auditing or any other purpose.
All right, so we've talked about some of the key features here. So as I mentioned before, one of the things, there's 2 questions I want to have answered about any product. One is, what's the problem? 2 is, okay, now how does it solve that problem? How does it work? We've touched on a lot of this, but I wanted to go into a little bit more detail of how Xage actually works. And we'll start with the fabric nodes, and then we'll get to the enforcement points as well, and that'll help answer some of your questions in the Q&A as well. So Xage is a dynamic mesh of fabric nodes. Essentially, there's a device. It's a proxy, but it's also a configuration store. It has a copy of the configuration. It's an enforcement point. It's an interface for users to interact with. So those nodes can be at any level in your network, including the cloud. They share policy. They are the devices that are one of the devices that are tunneling, building the secure tunnels, relaying credentials, relaying sessions, relaying files, and validating the integrity along the way. The biggest value or value add here is that sessions are terminated at each gateway. So you're not just tunneled all the way through all these multiple layers. Each gateway has an opportunity to stop or terminate the session, enforce authentication, multi-factor auth if necessary, access control specific to that location or specific to that layer, complete with approval workflows, session recording, and all of those things that come with session sharing as well. Did you want to add anything on the nodes here, Vishal?
No, this is good, Stephen. Thank you.
All right, and next up comes the fabric overall, and we'll put this in context with the enforcement points and the nodes. So the fabric itself is what we've been talking about. We've got centralized policy management, single policy, distributed a copy, I guess, or cloned across all of the nodes that replicates the configuration, any credentials, stored credentials, policy, configuration, all of those elements are replicated throughout the fabric, which primarily consists of 2 things: enforcement points and nodes. I already talked about the nodes, so quickly on that front, they terminate tunnels, maintain integrity, break the protocol, and allow us to do that multi-level authentication, as well as moving files around the environment. The enforcement points we touched on earlier, these are what I referred to as a transparent firewall, and Vishal can go into more details here. They are optional, but their key capability is controlling device-to-device access. So those legacy devices we talked about, by putting a Xage enforcement point in front of them, not necessarily individually, but in front of, say, a network segment or individually, we can control access with Xage to those individual devices based on user identity, device attributes, and so on. And they will also help us to discover and inventory those devices. So maybe I'll go back to the architecture slide if you want, Vishal, just to kind of bring this all together.
Sure. Yeah, so the Xage enforcement point, you see the bottom, you see a lock with the anti-clockwise arrows. That's a Xage enforcement point. It's a bump in the wire, and it solves, Stephen, you covered, it solves two purposes. One is the device-to-device interaction and optional data encryption between those two devices. Second, it provides you the ultimate protection for your assets at the very granular level. So suppose you got a site and where you have some key assets sitting in the field. If you put ZEP there, then that means anybody who is trying to access your assets on the site will have to go through ZEP. ZEP internally is inheriting all the policies that have been centrally managed in the Xage manager, and those have been synced at the ZEP. So even for the remote access, if you are coming from Xage, if you're using Xage as remote access, you will be granted access or you would not be granted access based on the policy. But in case somebody decides to bypass the Xage route and go straight and try to access through VPN or any other open setup tool to access your tools, your assets down there, they will be forced to go through ZEP. And ZEP, based on their user identity, will either allow them or will disallow them. There is a way for them to ask for approval, and that for that they will have to have an account with Xage Fabric, and we would allow that connection. But it is guaranteed that your any connection to the assets will have to go through ZEP, even if the site is offline, because the policies have been cached into ZEP. So whether it's offline or online, whether somebody goes through Xage or goes outside of Xage, ZEP provides you that protection at the very network level. And other part is that because it's a distributed mesh, fabric, every single time whenever you make any modifications to the policy centrally, it actually gets synced up really, really fast. So, and if your site goes offline and you do any policy changes centrally, when the site becomes online and gets connected to the rest of the fabric, it will synchronize all the policies again, and it will resync whether the users have access to your assets or not. So you wouldn't have to really worry about the operational aspect of the fabric. Everything happens automatically. All you need to do is, once we discover the assets for you, you define the policies and then start accessing your assets. As simple as that.
Awesome. Thanks, Vishal. A couple questions here. When we're talking about the ZEPs, the enforcement points, obviously, so can you talk, two questions I think came in really related. What do they look like from a physical port density perspective? And the question is, in the Q&A right now, do you have to basically disconnect one end of an existing network connection and plug the ZEP in the middle? That's my understanding, but how is it, how are you actually plugging it into your network?
Yeah, I mean, what you just said is correct. Your understanding is correct, Stephen. So ZEP is only one in, one out today. However, if there are use cases that require us to change the form factor and, support other use cases, we are more than happy to entertain and, work with you guys. No problem.
Awesome. And the second question is, what does the deployment and licensing model look like for many, many separate networks, like a commercial property management company with hundreds of buildings, something like that?
Yeah, so our licensing model is, is equally simple as a product itself. So we don't really license by the Xage nodes or Xage fabrics or other components. Xage enforcement point is a hardware component, so it has a hardware cost. But besides that, we only charge by the number of devices and number of users you have. So you want to protect X number of devices. It's devices. There's a license cost per year for a device, and there's a license cost per user for the device. And for the data side, it's like the data sources, the number of data sources is the cost. So it's basically what we're protecting is what we're charging for. But because our fabric, our solution has an inherent nature of distributed, you can deploy it in distributed fashion. We don't necessarily tax on that how distributed you want to go, because that's the essence of our architecture. But we only license for what we protect.
And in the case of 100 buildings, for example, I assume at the very least you would want a fabric node, which I'm also assuming could be a virtual machine at each of those locations.
That's right. That's right. And also it is not required. It is required because it gives you the flexibility that suppose you got 100 buildings and you want to protect access to the assets inside those 100 buildings, even if somebody goes there and try to access those assets physically in the site, you want to deploy a Xage node and a Xage enforcement point. However, if you want to manage those, like you want to segment that out of 100 sites, I want to manage 75 sites granularly and other 25 sites from an upstream side, you could do that as long as there's network connectivity. You can manage, you can have remote access from the upstream side as well.
And speaking of network connectivity, one more question just came in, which is, what about an environment with no internet connectivity at all? Obviously, Xage will still function in that model. How does licensing work? How's that imported, maintained, and so on? Is that just all done manually offline?
Yeah, I mean, I think once you have deployed the system, for the system to work or operate, it doesn't require internet access. Unless and until you want to make a remote access connection and the connection itself is coming from outside of the network, then you do need internet access. But we don't reach out or we don't need any connection. So for example, I mentioned about Azure AD. If you have Azure AD, you would need internet connection, but you could replace that with on-prem Active Directory. You don't need internet connection. And there is no implication whether you're online or offline, whether you have internet connectivity or you don't, it has no repercussion on the licensing. Licensing stays the same as we have filed as part of the enterprise contract with you.
Awesome. Thanks, Vishal. Just got a couple, actually one last thing to talk about to wrap this up, and then we'll take any other questions that you have as well. And that is keys to success. So I have seen over and over, I have seen organizations that go out and buy the latest cool technology like Xage, but then they plug it in and they look at the blinky lights and wash their hands, walk away and say, hey, cool, we got blinky lights. Like any product, any tool, it's only as valuable to you as the effort you put into it to configure it, to architect it, to implement it, and to make it your own, to make it do what you need to do. It's easy to install and configure Xage because you do have that centralized policy management and the inherent distribution of the policy, but you do need to think about how you want to divvy up your network, how you want to segregate both devices and users. What are the critical assets you want to protect? I wouldn't expect anyone to go in to 100 locations today and protect them all at once, right? Where are your pain points? Where is your most sensitive data? Where's security the most important to you? Start there. Think about, hey, we've got all of these users and maybe you have some sort of directory structure already, but do you have, I was talking to a customer yesterday, day before, and in many locations, they don't have Active Directory. In others, they have completely isolated independent directories. Xage can integrate with those, but is that what you want? How do you want to set up multiple directories to support something like Xage? And then within one directory, how do you want to lay out your users, your groups, your organizational units so that you can actually articulate permissions and articulate the controls that you want to enforce? So that directory structure is really important. So are people skills, organizational change management. as I mentioned, I've been on site many a time, and I get the, I've been here 40 years and nothing's ever gone wrong. What are you doing touching my stuff kind of conversation, right? It's really important to be able to explain what you're doing, what you're not doing, what risks you're mitigating, what risks you're not introducing, and how, as I gave the example earlier, you can put those ZEPs, those enforcement points, at a level that they can protect you from outside, from remote access from other sites. They can encrypt data between sites, but they can leave your site to operate as it has previously. That's a great first step at the very least, and maybe you leave it that way, right? So we're not going to screw you up. We're not going to come in and change the way you work. Certainly not on site. We might do that for remote access, but that's a different kind of conversation. However you do this, the organizational change management and the communication of what's happening, when it's happening, what the impact's going to be, what the benefits are, those are all really, really important components of any kind of deployment, but especially this kind of deployment. And the last piece, the last key to success is, of course, a good understanding of your network. You can drop Xage into any network, but if you have a good understanding of where those critical network or trust boundaries are, you're going to be much more successful much more quickly, right? You find those most critical boundaries, you've established those boundaries, so it's not a flat network, and now you've got a place to put in an enforcement point, a fabric node, and you can get those situated so that you provide the right access to the right people at the right time. So I think, like I said, have a plan, I guess. If I were to summarize this slide, it's have a plan and communicate that plan.
Yeah, one more thing I would like to, maybe there was a question, Stephen, that was asked about that there are 100 buildings, 100 different networks, and how can we deploy Xage Fabric? So Xage Fabric is as you would understand that there is some data sharing that happens across Xage Fabric because everything has to be synchronized. So you have an option to have one Xage Fabric spanning across multiple networks as long as they have interconnectivity. However, if you decide that I've got certain networks that should not have any data sharing via Xage with other networks, you can choose to deploy a separate fabric with a separate management plane with separate policy management. And we have customers doing so for certain sites. And so you can go that, and as I talked about, that doesn't have any implication on the licenses because the number of devices is still the same. How you deploy the fabric or you deploy multiple fabrics have got no repercussion. Second, even if you want fabric to fabric connectivity, for whatever reason, we can give you a secure connectivity across our fabrics as well. So it's as Stephen said, that know your network, know your needs. Our product can actually scale to your needs in the most hardened way. So it's up to you how you want to use the product and deploy and secure stuff.
All right, awesome. That brings us to the end of our prepared presentation. We've got a few minutes left. However, if anyone has additional questions, please put them in the Q&A. And I think Mary Lynn's been collecting some as well for us.
Yes.
If there aren't any more.
We do have a few more questions ready for the Q&A. This next question is a multi-part question. Who are your customers? What companies are already using this? Can you tell us about the actual impact this has had at an actual customer of yours?
Yeah, so we've got customers across many verticals. We got customers in federal, we got customers oil and gas pipeline, and we are working with many others across the verticals. Energy is one of the vertical where we have seen the huge traction because our story dwells well really with the energy because the assets are really legacy assets and they can't really apply security and they cannot rip and replace. So our being an overlay solution works really well in that kind of setup. One of our, we have done recent case study, a public case study with one of our very important customer, Kinder Morgan. If you don't know Kinder Morgan, they actually operate 40%, they transfer 40% of their oil and gas across North America. So they had 3 problems that they brought to Xage. One, they had the assets and they wanted access to the assets in a way where when a technician comes in, if he does VPN, he will have access to more than one asset. They wanted to segment their assets in a way that they can define which technician can access which asset at what point of time. They wanted strict access that nobody should be able to access the assets during certain hours. Number two, they had a use case where they wanted to make sure that they wouldn't have to store important information as part of files on the network, because they wanted to share the files across their multiple admins and operators. Third, they wanted to make sure that every asset, whether it's PLC or SCADA system, is protected at the asset level. So they've got every other tool that market has to offer today, but they couldn't guarantee that if I want to protect a specific SCADA system, how do I make sure that only certain parties will have access to that? So they evaluated many other tools, and they finally decided upon Xage, because Xage actually offered them a solution that solved all the three pain points in a very dramatic and a fast manner. That is, that they can manage, they can define the policies for that, and they can see the result that, yes, now since I've applied the policy and I've given the access to the SCADA system to two people in my entire organization, nobody can access, and every access connection is getting rejected at the network level.
Perfect. There's another question that came in as well, asking to expand on how the ZEPs work for encrypting device-to-device communication. And I think the answer in this case is if you want to encrypt communication between two devices legacy devices, I'll call them, you're going to have two ZEPs. So that would be from a location to location over a wide, it doesn't have to be, but over a wide area network kind of scenario. So it's not just a single box that's going to magically encrypt communications. You're going to encrypt at one end with a ZEP and decrypt at another end with a different ZEP. Is that a correct understanding, Vishal?
That's right. I mean, we are pretty much encrypting the entire traffic that's coming from into a ZEP from a particular device. So when you put ZEP in front of devices, so set of devices will be sending the data, and it's going to go through ZEP, and ZEP is going to have its own unique key that it's going to use to encrypt at the ingress, and it will make sure that it decrypts the data at the egress if you want to take the data out.
Perfect. Yeah, it's between two ZEPs, two different devices.
That's right.
We have another question out there. What technology does this replace? And what can I get rid of if I buy Xage?
There are, if you look at the problem that we are solving, we are giving the asset protection. So any tooling that you're using today that is helping you protect your assets or claiming to protect your assets from cyber attacks, we could replace those tools. We are solving for remote access, which means that any tool, anything that is not working out for you, or for whatever reason is difficult to maintain, and you want a way for a simple browser-based remote access that gives you all the bells and whistles, we can replace all such tools. Third is the data problem. Whether you're using, depending on your needs, if you're using gateways or any other technology or homegrown technology to protect your data and being able to audit and check the integrity of the data, those tools can be replaced. So, and you can imagine that all these tools are separate tools. So when you bring in Xage and protect your organization, you are not just replacing the tools, you are saving a lot in the operational cost as well as the user experience, because once you have learned how to use Xage, which is very easy from the browser access, all you are doing is just enabling the policies, and you are getting the protection or remote access or the user management, access management right out of the box without actually doing anything else at the network level.
Looks like
Awesome. And you can map that at least loosely to the 5 critical controls as well. It's these 3 in the middle that Xage is primarily covering off.
Absolutely.
There's one more question. Who's your closest competitor that came into the Q&A there?
Well, we compete. I mean, we compete with the technologies such as any technology that actually leads to a lot of vulnerabilities, such as VPNs or remote access that have got thick clients, or access management that is IT-driven access management and not really designed for OT. We compete with all those tools, and that's our competitive landscape as it stands today.
Well, it looks like that's all the time we have for today. Thank you so much, Stephen and Vishal, for your great presentation, and to Xage Security for sponsoring this webcast, which helps to bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thank you.
Thank you.